Bismillahirrahmanirrahim. In the previous unit, we explored the fundamental building block of communication system, providing an overview of how information travels from source to destination or from one point to another point. Now we are going to dive deeper into each of these components to understand their individual role and how they work together. We will start with the source of information which generates the message to be transmitted. Next, we will examine the transmitter which convert the message into a suitable signal for transmission. We will then look at the channel, the medium that carries the signal, and the antenna which play key role in sending and receiving electromagnetic waves through the channel. After that, we will discuss receiver, which extract and reconstruct the message, and finally the destination system, where the information is delivered to the user. By the end of this unit, you will have a very clear understanding of each block and its importance in communication system. Let's begin. Let's take a moment to understand the difference between data and information. Data refers to raw, unprocessed facts and figures. It can be a number, it can be a text, it can be image, or any form of recorded input. For example, list of temperature recorded throughout the day in data. For example, 23 degrees centigrade, 44 degrees centigrade, 55 degrees centigrade. Similarly, on its own, data might not make much sense or provide insight. On the other hand, information is what we get from process and interpret one data or more than one data, as shown in the block diagram. It gives data meaning and context. For instance, analyzing those temperature to determine the day average or identifying a trend convert data into useful information. In essence, data is a building block, while information is the meaningful outcome coming after processing of data. Both are essential in decision making, problem solving, and driving progress in our digital world. Let's explore the source of information, which is the first building block in a communication system and the process of converting a non-electrical signal into electrical signal for transmission. The message produced by the information source is not initially electrical. It can be anything from a voice signal in a phone call, a picture in a video feed, or even a text message. These type of signals are typically in the format that our system cannot directly transmit. To make suitable these message for transmission over an electronic system, we need an input transducer. The role of such device is very crucial. It converts the original message, whether it is a sound, image, video, or text, into time varying electrical signal. For example, in a voice call, the microphone acts as an input transducer, converts the sound of your voice into electrical signal that can be transmitted. Once converted, these signals are referred to a message signal or a modulating signal. These signals contain all the information we wish to communicate and they serve as a basis for the next step in the telecommunication process. It may be analog, it may be digital. But the key point here is that regardless of the source of message, it must be converted into an electrical signal before it travels through the communication system. So finally, the process begins with the message that acts as a non-electrical in nature, but thanks to its input transducer, it transforms into modulating signal that can be transmitted efficiently to the receiver. This conversation is fundamentally for any communication system is very crucial. whether it is simple phone call or a complex data transmission. Now I will discuss a key concept in the world of communication, the role of transmitter in converting message to effective communication. For its core, a transmitter is an electronic system comprising various electrical and electronic components, and its primarily job is to convert a message signal into such form which is highly suitable and form that can be propagated over a communication medium such as twisted care, twisted pair cable, air, or fiber optics. To understand this process, let's break down its into essential components. When we communicate, whether through a voice, data, or even video, the message will want to send it typically is a baseband form. This could be a analog signal like sound or digital signal like a binary stream of data. However, this raw signal cannot travel directly over a most communication medium. That we need in such a way to adopt it so that it can propagate over a long distance with minimal losses and distortion. This is where modulation comes in. Modulation is the process of varying a carrier signal to encode the message signal. This carrier signal is usually an electromagnetic wave, typically a sinusoidal waveform that has a specific frequency. This carrier wave is modified by the message signal to create what we call a modulated signal. The beauty of modulation lies in its ability to make the message signal suitable for travel across the communication system. There are different type of modulation, but they will involve altering the carrier wave in one of the three key ways by changing its amplitude, by changing its frequency, or by changing its phase. This allows the transmitter to superimpose the information we want to communicate onto the carrier wave, transforming the message into the form that can easily propagate throughout the air or through cable or through fiber optics with minimal interferences or noise or signal degradation. The modulated signal is what we send through the communication medium, whether it is a radio wave traveling through the air, light pulses traveling through the fiber optics. At the other end, the receiver pick up the signal and demodulate it and extract the original message. To put it simply, think of modulation like a translator that takes the original message in one language and translates it into another language. We call it modulated signal. That is better suitable for the transmission. This is why modulation is such a fundamental aspect of modern communication systems. Without it, we could not be able to transmit signal over a long distance or through different type of media. So finally, we can say that transmitter role in converting a message signal into modulated signal is crucial for ensuring that the message can be efficiently and accurately transmitted, whether it is a radio station broadcasting your favorite music or a satellite sending data across the globe. Modulation is the heart of how information travels. The antenna play a crucial role in transmission process by convert the electrical signal generated by the transmitter into electromagnetic wave that can travel through the air or other communication medium. While the transmitter encodes the message into a modulated signal, the antenna radiates this signal outward, allowing to it propagate over a long distance. It essentially acts as the interface between the electrical component of the transmitter and the external world, ensuring the signal is transmitted sufficiently with minimal energy loss. Without the antenna, the transmitted signal would have no way to reach its destination. As electromagnetic signal is generated from an antenna when electronic alternating current passing through it because AC creates both electric and magnetic fields that propagate as an electromagnetic wave. Here, how can happen in simple terms we will discuss first of all. First of all, we discuss about alternating current in antenna. When AC current flows through the antenna, the current changes direction periodically. We call it as oscillate. As the current oscillates, it creates a time varying magnetic field around the conductor following the Ampere's law. In the second phase, electric field is generated. The oscillating current can cause charges to oscillate back and forth in the antenna, which generate a time varying electric field. This occurs due to the Faraday's laws of electromagnetic induction, which states that changing magnetic field induces an electric field. A magnetic field formation we will discuss here that time varying electric and magnetic field interact with each other. A changing electric field generate a magnetic field and changing magnetic field generate an electric field. These fields reinforce to each other, forming a self-sustaining electromagnetic wave that moves outward from the antenna. Propagation of the wave. Now we will discuss propagation of the wave in the media. The electromagnetic wave travels away from the antenna at the speed of light. The direction of the antenna and magnetic field is perpendicular to each other and to the direction of the wave propagation and forming a transverse wave. Just for example, coil antenna. In a coil like an inductive loop antenna, a AC signal passes through the turn of the coil create a stronger concentrated magnetic field due to the loop geometry. As the AC alternates, the magnetic field expands and collapses, inducing a associated electric field. Together they radiate an electromagnetic wave outward. Now question is that why AC is important and because DC current cannot generate electromagnetic wave because the field is produced as static, unchanging. Oscillation in the AC current is necessary to produce the time varying field needed to for the wave propagation. So, in summary, we can say that antenna generate electromagnetic waves when an AC signal causes oscillation electric charges, creating alternating current and a magnetic field that propagate outward as the electromagnetic radiation. This AC signal is generated by the transmitter and which is attached to the antenna and hence electromagnetic signal propagate in the media. Now we will discuss another building block of modern communication system channel. Channel is basically a separation of transmitter and receiver. It may be a simple coaxial wire, fiber optics or free air. The transmitter and receiver are typically located in different physical locations. Such separation is filled either coaxial cable, fiber optics, or free air itself. We refer all these mediums as a channel with essential for the success of electronic communication. Now we discuss the role of the channel. The channel is the medium that connects the transmitter and receiver and it carries the signal from source to destination. There are different type of channels. Coaxial cable used for the wide communication such as television or some hardwire internet services. And similarly, microwave link is another form of channel used for high frequency point to point communication. And radio wave link, it is another common in wireless communication system like broadcasting and mobile network. Fiber optics is another form of channel used for high speed data transfer with a light signal. Now, it is understood that when a signal passing through the channel, it degrades. Every type of channel affects the quality of the transmitted signal. And there are many issues related to that. Most important is signal distortion. Signal distortion means that alters the shape of the signal, making it harder to interpret due to the noise present in the channel. Another is interferences, unwanted signal that interface with the original message and create some noise interferences. Attenuation, loss of the signal strength in terms of power or in terms of voltage or current over a distance we are considered as a attenuation. All these degradation has some serious impact on the quality of the communication system. Degraded signal may result in error, requiring technique like error correction or amplification to improve the communication quality. Noise in channel disrupt the signal and can occur due to several factors. One of the most important is imperfect channel and system response. The channel or system may not handle signal perfectly and introduce some distortion. Similarly, undesirable electrical interferences is another reason for the noise. External electrical signals such as from nearby device can interfere with the intended signal. And insufficient channel bandwidth. Limited channel bandwidth can also cause some part of the signal to be lost or overlap, leading to the distortion. Similarly, contamination with the other signal can also create the noise when proper measurements are not taken to isolate a signal with other unwanted signals which are already available in the media may mix with the transmitted signal and can generate a noise. All these noise as discussed has some serious impact on the quality of the communication system. Most important is that they reduce the signal clarity and quality. This noise also lead to errors in the data transmission, particularly in digital signal as well as in analog signal. Require noise reduction or compensation technique for effective communication system. Therefore, in order to design efficient, we have to design such communication system which can compensate the expected noise in the channel. Now we turn our attention to a critical component of our communication system, the receiver. The receiver plays an indispensable role in ensuring that the message we send and received are not only clear but also reliable. The primary function of a receiver is very simple. At its core, the receiver's primary function is to extract the message signal from a degraded version of the transmitted signal. In the chaotic world of communication, where various forms of interferences and noise can direct or distort our messages, this task is very crucial. The receiver must sift through the noise to uncover the intended message, ensuring that what we communicate is accurately delivered. So, for that purpose, we have to perform some design consideration for receiver. To achieve this, both transmitter and receiver are important to engineered with specific design consideration aimed at reducing noise as much as possible. Key among these considerations are minimizing distortion. We must ensure that the original message is preserved in its transmission. Distortion can lead to the misunderstandings and misinterpretation, which can be detrimental in both personal and professional communication. Reducing noise impact. Actually, noise can come from various sources: electrical interferences, environmental factors, and many others. So, therefore, our systems are designed to mitigate these effects during both signal transmission as well as reception, allowing for clear communication. Now, the third one important thing is signal reconstruction. Once the receiver has processed the incoming signal, it engages in the complex task of signal reconstruction. The goal here is to restore the original message signal as closely as possible to its original form. This process involves sophisticated algorithms and techniques that work tirelessly to compensate for the any type of alteration caused by the noise or distortion during transmission. And the most important task of the receiver is final delivery. After reconstruction, the newly formed message signal is delivered to the intended user or destination. This final step is where the magic of the communication happens. The information is presented in its way, such a way that it comprehensible and useful to the recipient, fulfilling the purpose of our communication efforts. The importance of the receiver cannot be overstated. It ensures accurate and reliable communication, compensation for channel imperfections, and the effects of noise. In an age where instant and effective communication is paramount, the receiver stands as a guardian of the clarity and precision. So, in conclusion, we consider that the building block of communication system as a most important receiver. So we, by understanding and appreciating its function and challenges, we can continue to innovate and improve our communication technologies, paving the way for clear construction or connection in our increasingly interconnected world. Finally, we discuss about destination, which is output transducer. It might sound technical, but it's something we encounter in our everyday life, perhaps without even realizing it. Imagine you are listening to your favorite song on a radio or speaking to someone on your mobile phone. What's happening in this system is a complex journey of signal transmission, and the final step of that journey bring you the output transducer. So what is the output transducer? Simply put, the device that receiving the end of a communication system that convert electrical signal back to its original form. The form that we are human, we perceive and understand. For example, in a mobile communication or during radio broadcasting, the speaker acts as a output transducer. It takes the electrical signal, it receives and converts back into the sound signal we hear. Let's think of this process in terms of destination. Every journey, whether it is a personal traveling or signal being transmitted, has a destination. In the context of communication, the output transducer is the destination. It completes the communication loop, ensure the message that starts at the transmitter is faithfully delivered to the original form to the receiver. Without the output transducer, the signal would remain unintelligible to us. Mere electrical pulses, just like a electrical pulses. It's the critical component that bridges the gap between the technologies and the tangible. To illustrate the important, consider a world without a speaker. You would see signal being transmitted and received, but you would never hear the music, the voices, or the alerts. It is a speaker, the humble and yet powerful output transducer that make it all possible. In conclusion, the output transducer is unsung hero of the communication system. It reminds us that while technology can work wonder, its ultimate purpose is to serve human needs, delivering the message, the music, or the voice, or video exactly as intended. And so the destination in every communication system, without a doubt, the output transducer. Thank you.